recording. So in problem 3, we want to find the area between y equals e to the minus x and y equals this parabola. Presumably, we're looking for above the e to the minus x and below the 7 times x minus x squared. The area between them before they intersect is infinite, and the area between them after they intersect is also infinite. So I'm guessing that we want this area in between. We know that we're going to be doing some kind of definite integral. So we need to find out where they intersect so we'll know where to integrate. So first we need to find these intersections, and then we'll be able to integrate from a to b. I am going to mechanize the finding of the intersections. There's a couple of ways that we can do this. I'm going to calculate, one of the functions on my calculator is an intersection, and it's going to ask me 3 questions. First curve, a second curve, there's only 2, so I just hit enter a couple times, and then a guess. So I move the cursor over to where it looks, it's close to the intersection, and then you hit enter, and then the calculator will zero in on it for me. So I use my calculator to find the first intersection at 0.1445. I just need the x values. And then I can do the same thing for the other intersection. So I'll second calculate and intersect first curve and second curve, and then I'll move the cursor over to where the other one is. And it tells me that one is at 0.9407. Once again, just need the x because that's the one we're integrating, the variable we're integrating over. So the other thing that we want to do is we want to integrate what we're going to integrate. Now that we have those intersections, I'm going to integrate the function on top is the parabola. So from 0.1445 to 0.9407, this integral will give me the area. I don't want to write these all the time. This definite integral will give me the area under the parabola between a and b. And then I'm going to subtract the area under e to the x. So I'll subtract the integral from a to b of e to the x dx. Properties of integrals, since that's the whole thing going on in this particular section, means that we could just make this into one integral by subtracting the 2 functions. So I could just take 7 times x minus x squared minus e to the minus x dx in one big integral. And I'll go from 0.1445 to 0.9407. And this I'm just going to automate. So I'm going to quit out of this, math 9, and then I'll just plug in what we need. The function is 7 times x minus x squared minus e to the minus x. With respect to x from 0.1445 to 0.9407. Okay, come in. And so we get 0.613 decimal places, so 0.614. Any questions? We could also integrate this on our calculator from the graph, now that we have the values. If I switch the graph to, I'll turn these 2 off, and I'll just make the graph of the parabola y2 minus the exponential y1. Oh, it's got to think for a while. There it is. And we'll just calculate second, calculate a definite integral from 0.1445 to 0.9407. And that gives us our 0.614. Any questions? If we want to put this into Desmos, I don't know where my Desmos machine is. If you want to put this into Desmos, I can't remember how to calculate integrals on Desmos. I'm not sure that it does. But if you put the two functions in, if you put these two functions in, it's easy to find out where they intersect. You just have to tap where they intersect and it'll find the intersection for you. Any questions? Let's pause the video here and talk about some more problems.